Today I thought I'd take a look at one of my recent eBay finds. It's an Applied Biosystems 373 DNA sequencer. The system came with an old Apple Power Mac system, so I'm going to see if I can get that up and running first and see if it still has the DNA sequencer software on it. Okay, got it all hooked up. Let's see what we get.
Power button got smashed in at some point.
Hard drive does not sound healthy.
This finally got this thing booted, and it looks like the last time this thing actually sequenced anything was on January 21st, 2002. So this thing's been sitting around for about 10 years. Be interesting to see if the argon laser inside of the sequencer still starts up. And looks like it saves the actual sequencing data in a simple text format. And those are just all the base pairs that it sequenced during that run.
It also came with this little box. It's a translation processor for the sequencer. The translation board is fairly basic. It's got Motorola MC68332ACF C16, which is a 32-bit processor, firmware on a chip, some serial communication, 2 Xilinx chips probably for handling proprietary data, and some assorted memory chips. Well, I got the front panel off, so I figured I'll start it up at least once before I completely destroy this thing. Looks like this thing might be dead. Aha.
sound healthy. Okay, so the battery's dead. I guess that passed. The laser is actually putting out 7 milliwatts at 4 amps. That's pretty good. Laser's working. Not bad. Okay, I got the front panel stuff mostly taken off now, and one of the first things you'll notice about stuff like this is that a lot of the components that they use are highly modular. You can actually just pull a lot of this stuff out and reuse it as it is,
it's not all smushed down into one single board for low-cost manufacturing. So on the left you've got the high voltage electrophoresis power supply. At the top is the laser power supply. Bottom is power distribution. In the middle there's all the electronic cards that operate the various equipment. And then on the right you actually have the mechanical assembly that does the scanning of the DNA samples. And this piece is the main optic stage. It's basically just a little linear actuator to move the read head back and forth. Laser beam comes from the laser in the back, bounces off a mirror, another mirror, and enters in through here. And then it comes out this aperture here and is directed upwards into the sample that was on this little holder over there on the front of the unit. The light comes back in through probably like a dichroic mirror or something, passes back into the read assembly. There's a stepper motor here which rotates a color filter wheel inside and selects the wavelengths that they are specifically looking for, and then the actual data is collected by a photomultiplier tube which is installed in here. There's the photomultiplier tube. If I can get it to focus. Alright, this is one of the main This is one of the main input boards. This is one of the main control boards, and it mostly contains stuff like motor drivers, sensor input logic, and analog to digital conversion. The second board contains the main digital processing, including the Zilog Z80 processor, a 5-volt power supply, and the actual firmware, which comes on this little plastic cartridge. It's basically just a little plastic cartridge with a bunch of EEPROMs inside. Now I'll take a look at the high voltage power supply. High voltage power supply is fairly basic. You got basic linear components here controlling the regulation of the output. And there's the DC power transformer, the transformer supplying DC power to the control electronics. And then for the actual high voltage supply, you've got two fairly beefy MOSFETs dumping power into this little flyback, which is rectified by a stack of diodes and fed into these capacitors, these big film capacitors. Now let's take a look inside the main power distribution box. Now it looks like this one's a little bit of a different design over the one I took apart previously. This one has the same two linear power supplies, but this one has a fairly beefy contactor in it. The other one I took apart had another one of these solid state relays. There's a little board over here which contains two small solid state relays and some basic power supply componentry for running all the power interlocks and stuff. Now here's one of the main reasons why I bought this thing. This is the Psionics Uniphase argon ion laser that was inside this latest unit. This one was made in '98, so it's actually a pretty recent laser as far as ions go. So this has a sticker here, so it looks like it has been replaced at some point, since the sequencer itself was built in '95 or '96. I'll get this powered up in a little bit. Okay, everything's been torn apart. These are all the good components that I think are worth saving out of the unit. There's the high voltage power supply. There's some nice film capacitors, the MOSFETs, the flyback. You could rewind that if you wanted to. There's plenty of good components on there. The two main boards, there's plenty of chips on there that you could reuse. It's all through hole. There's metal can op amps and voltage regulators, all plenty of stuff that you could use. The two motor driver chips, they're just generic H bridges. I think you can just reuse those if you wanted to. There's two little solid state relays on there. The main board, there's crystals and some reed relays. You could reuse a lot of the chips on here. 5 volt, 5 amp power supply, that could be useful. There's a photomultiplier tube. Two nice Swiss made motors. One's just a regular DC motor with an encoder. The other one's a stepper motor. There's two adjustable Newport mirror holders. Nice lens. Two pretty nice power supplies. This one's 24 to 28 volts at half an amp. Bigger one is 24 volts at 4.8 amps. There's a 25 amp solid state relay, fuse holders, terminal block, line noise filter, nice contactor, a line voltage cooling fan. There's this little circuit board here has 4 mercury switches in it. Don't want to throw those in the trash. Whole bunch of ribbon cables and miscellaneous wiring that could be reused for projects. Of course, there's the ion laser, that's a whole unit in itself. These aluminum cases you could reuse for other miscellaneous projects. And the main base plates in the unit, they're pretty decent sized aluminum. They would be good for maybe some laser show equipment or just a good solid mounting plate for other miscellaneous projects. So that's about it for the DNA sequencer. Now I've got my fog machine fired up, so let's start up the argon laser. Goes. Let's see what we're doing here. Not bad for idle. Alright, now I've got the jumper installed to enable the current control on the front of the power supply. So now laser beam should get brighter once I turn this up a bit. And we're doing about 38 milliwatts. We've got 1, 2, 3, 4.
7 lines. It's kind of hard to tell, there's a lot of spatter. Camera doesn't really show it too well, but the lines actually range from a good forest green through to a light blue, dark blue, and all the way down to a violet.
Not bad for a first run, considering this laser probably hasn't been used in about 10 years. That's about it for now.